Hi everyone, welcome back to my next session. In my previous lecture, we discussed about the fusion strategies. In fusion strategies, we discussed about what is sensor level fusion as well as the feature level fusion that comes under the prior to matching. Now we are going to discuss about what is after matching. What are the fusion strategies that comes under after matching? I mean prior after matching, and there we are going to discuss about the score level fusion. In score level fusion, we are going to discuss about the similarity score as well as the dissimilarity score. And then we are going to discuss about the rank level fusion. And in rank level fusion, we are going to discuss about the Borda count as well as the logical regression method. And finally, we are going to discuss about what are the errors that are available in the biometrics. Now I'll be sharing my screen. So score level fusion. So this is the first topic that we are going to discuss by today. So if the samples are coming from the same person, then it was represented as a similarity. If the samples are coming from the different persons, so that is known as the dissimilarity. If it is similarity, it is coming from the genuine user. So if it is not, if it is a if it is coming from the different samples, so it is not a genuine user. So we'll be mentioning as a imposter. Okay, now we can move into the rank level fusion. So I'm taking out the multiple persons. So I'm going to follow the three traits for each and every person. So now for person one, I'm going to use three traits: face, year, as well as a signature. For person two, again I'm going to use a three traits: face, year, as well as a signature. For person three, again I'm going to use face, year, as well as a signature. For person four, I'm just going to use only two traits. So face as well as the signature. For person 5, I'm not going to use a multiple biometrics. I'm going to use a uni model. If I'm going to use a uni model, we cannot find a board account as well as a logical regression for the uni model. So we have to find the we can find only the board account and logical regression only for the multiple biometrics. Now, identity for the person one. Now I'm going to find out the fused score. How to identify the fused score? So face, year, as well as the signature. So three traits I'm going to use. So divided by 3. So 3 plus 2 plus 1. So 6 divided by 3. Similarly, for person 2, 1 plus 1 plus 2. So 4 divided by 3 equal to 1.33. And for person 3, 4 plus 4 plus 3, 11 divided by 3. So person 4, so 2 plus 4, 6 divided by 2. So according to that, the fused score was found. Through the fused score, the reordered rank will be found. Now I'll be moving on to the logical regression. As of now, I explained was the board account. Now I am moving on to the logical regression method. So what is the actually what how we have to find the logical regression is that fused score we got. So 2 divided by how many traits I used for a person? 1, 2, 3. So 2 divided by 3 equal to 0.67. And similarly, what is the fused score for the person 2? So 1.33. So 1.3 divided by 1, 2, 3. So 1.3 divided by 3 equal to 0.43. And what will be the fused score for the person 3 here? So 3.67. So 3.6 divided by 3 will be 1.23. Here there is a mistake. It should be 3.6. And last for the person 4. So 2 plus 4 equal to 6. So 6 divided by 2 equal to 3. So here it was in the PPT, it was mentioned as 1.8. It should not be 1.8. It should be 3. So 3 divided by 2 equal to 1.5. So now according to the rank level fusion, I found what is a board account as well as the logical regression method. In score level fusion, we discussed about what is the similarity score as well as what is the dissimilarity score. Now we can move into the next topic called what are the errors that are available in the biometrics. How the errors that are going to occur in the biometrics because of the illness. So if we are ill, we won't be brisk. So automatically there will be, in case if I'm using a face or something, there will be change in a face due to the fever or due to the illness or something. So during that time, there can be a failure in the biometrics. Then the sensor itself may be a failure. And then the data processing. In case whatever the data that we collected, it is of low quality of data. So automatically next day, if you are coming, if you are marking our identity, so the data processing will be very difficult because of the low quality of the data. So I'm going to explain about the formula, right? FTA equal to number of the failed attempt equal to, so divided by the number of the all the attempts. So I'm keeping for the first 10. Automatically what it will be happening in case if the low quality of the data or if there is a data processing failure, automatically biometric system won't recognize. Again, I will be keeping next time if the light quality is good and the quality of the data is good and it can recognize. So 1 divided by 2 equal to 0.5. That will be the value for that because failed attempt is 1 and next time is got succeeded and total attempts I made is 2. So 1 divided by 2 equal to 0.5. Next, we can move into the failed to enroll. So automatically, if you are not enrolling, automatically the biometric system won't recognize this. So FTE equal to, so number of the failed enrollment divided by the number of the all the enrollment. So what are the biometric system needed? So all the things detailedly we have to give each and everything for the enrollment. So if you are not giving the proper enrollment details, automatically it will be resulting in error. Like still I need a data. So again, I'll be adding all those data and I'll be giving. So automatically how many attempts I made? 2 attempts. Initially, I made one failure and next, whatever the data I needed, I checked it and I give it. So 1 divided by 2 equal to 0.5 again. Now, we can move into the types of the biometrics. So, genuine, imposter, and skilled forgeries. So, genuine means it is coming from the genuine user. I mean, 2 samples are coming from the same person. So, imposter means first 2 samples that will be coming from the different persons. And skilled forgeries means some persons will be trying to imitate as like us. So, if you are using the fingerprint, what they will be doing as like us, what they will be doing is that they'll be using a gummy finger. Or what they'll be doing is that if it is a gummy finger, we can take an example as a physiological traits because we are using a gummy finger as for the fingerprint. If it is a like mimicries or something, that can be coming under the behavior. I mean, whatever the types of the biometrics we are using, there will be a failure. I mean, there will be a security issues. To overcome that, what you have to do is that if you are enrolling it or something, if you are marking, if you are collecting some inputs from the user, what you have to do is that we have to keep all the inputs one side. And again, someone is coming for the enrollment, it has to check with the input which I already collected. So we have to match it and check it. So if it is matching, what you have to do is that we have to look that into the very carefully and who is not a genuine user, we have to identify by collecting the inputs again. So this is how we can avoid the confusion. So next we can move into the feature matching as well as the decision making. So matching is a system that makes the 2 samples of the biometrics data and returns the scores that indicates their similarity and dissimilarity. I already explained. It is coming from the same individuals, then that will be represented as genuine. And if it is coming from the different person, it is not coming from a genuine person. So automatically it will be considered as a dissimilarity. So it is a similarity means according to this, 2 samples are matching, H naught. And H naught means 2 samples are matching and automatically H naught will be represented as a true. If 2 samples are coming from the different person, so automatically that will be represented as a dissimilarity and automatically that will be considered as a false. Okay, so H naught means it is a similarity, H1 means it will be represented as a dissimilarity. Now we can move into the terminologies. So mistaking the biometric system from 2 different samples to be from the same person. So different biometric systems are recognizing, right? Different samples. I mean, person 1 and person 2. Okay, they'll be having the different samples, but the system is recognizing like it is coming from the same person. So it is known as a false match. And both the samples are collected from the same person, but biometric system is recognizing like it is coming from the different person. It is known as a false non-match. So both are false things only. So one is FM and another one is a FNM. So both will be rejected because both are having the errors. So that's what. So false match means that is represented as a type 1 error and FNMR means that is coming from the that is also a fault. That is also one error, and it is coming from the. It will be represented as a type 2 error. Okay, observations. So even though the two samples are coming from the identical, the similarity scores will be rarely one, unless the two samples are copy of the each other, but the score is usually high. If two samples are coming from the same person, and automatically it will be represented as a genuine score, and automatically the score will be very high, and it will be represented as a 1. And even though if the two samples are coming from the different individuals, and automatically the score will be represented as a 0, and automatically it will be represented as a imposter, and automatically that will be considered as the dissimilarity. Okay, in this lecture we discussed about what is core level fusion, and in rank level fusion we discussed about what is the Borda count, and then we discussed about the logical regression method, and then we discussed about what are the errors are there, and then finally we discussed about the observations. Okay, and in the next lecture we can discuss about the LDA problem. Thank you. Now I'll be stop sharing it.